So we have said so many things, but ultimately the question is whether these different kinds of El Niños have something in common. We said there are Central Pacific El Niños or Dateline El Niños, East Pacific El Niños, Extreme El Niños, and so on. And we said not every El Nino is different from the other. So teleconnections will be different as well. But what does that mean? Is there something really common to all of them? This paper argued that the recharge discharge process in all of them is essentially the same. So the idea was to see how and when the discharge starts. And if you look at the subsurface, so this is depth, and these are the longitudes as we saw before, averaged over 5 south, 5 north, and the thermocline is shown here in these colors, and we are looking at different periods, 1950 to 1976, looking at June, July, August of the previous year. So if 2026 is an El Nino, then you look at June, July, August of 2025, and it shows that basically the discharge seems to start 1 year before, the summer of the year before. So June, July, August of year -1, September, October, November of the previous year, December of the previous year into January, February of this year. So December 25 into January, February of 26. And you can see it begins to spread. And by March, April, May, it has spread here. The trick was then to see other regimes. We talked about the regime shift before, and we said, animations are always a problem when you do this. So we talked about these regime shifts where people claim that we have gone from Eastern Pacific El Niños to Central Pacific El Niños, and that their frequency is increasing with global warming and so on. Obviously not necessarily always true, because 15, 16 El Nino and this El Nino seem to be very much like the canonical or East Pacific El Ninos. So that's how the Central Pacific El Nino looks like. Cold in the east still, but warm over here, has different teleconnections, etc. And the connection to global warming was claimed via changes in thermocline depth, shifts in thermocline depth, but turned out that those are not solid claims. But here, coming back to recharge discharge, looking at 1977 to 2000, because this was a regime shift in the 1970s, which is visible in biology and many other things, maybe even in the monsoon and so on. And the more recent period, 2001 to 2007, this paper is a bit old, but nonetheless, that was the last El Nino they had to analyze. And you can see that these periods, they look similar here, maybe somewhat similar here, but this begins to look quite different. It turned out that the mean state itself can change over such a long period. For example, if you have an El Nino and it's moving warm water around, and it goes back to shallow thermocline in the east and deep thermocline in the west, will it go back to the exact same state as before, or will the climatology or the background state or the basic state or the climatology, as I said, change? So what they did was, take the climatology of each period and show that when you account for the change in the background state, all the decades look the same. I think, in fact, this was after the climatology was changed, and then they argued that all the recharge discharge look the same in each decade when you account for the change in background state. So one could presumably argue that the recharge-discharge process indeed is very fundamental to El Nino, even though its surface expression may look different. It may look like this, it may look like a thermally coupled Walker mode, it may look like a Central Pacific El Nino and Extreme El Nino, and so on and so forth. Okay, so it makes sense in the sense that makes sense in the sense it makes sense to the extent that there is an east-west asymmetry. Normal conditions and La Nina conditions have cold SSTs in the east, warm SSTs in the west. There is a recharge going on because every time you have cold SSTs in the east, the atmosphere tries to warm the cold water that is brought up from below, which means the ocean is soaking up heat like a sponge. That heat that is accumulating gets discharged every few years. This is a fundamental process. Makes sense? Then the question is, why do surface manifestations of El Nino change? Why do they sometimes look like East Pacific El Ninos and sometimes like Central Pacific El Ninos? There are many theories by now, depends on the mean state in the thermocline as well as other details, but as of now, I would say we don't have a very clear answer as to whether these are really independent modes of El Nino or just El Nino has a diversity of flavors of El Nino, as some people call them, or diversity of El Nino, that they're all part of the spectrum of El Ninos, that they all have recharge discharge, they all evolve, they all have coupled feedbacks, even though it looks very different here. The recharge discharge pathways are supposedly different for Central Pacific El Ninos than East Pacific El Ninos. So people try to explain what happened. They are not always able to help predictions with that. And El Nino prediction skill is very high, as we said, but you can always fail as well. This year was very good. I think 23-24 El Nino was very good as well, but 24 La Nina was a big bust. So you have to be always careful. Okay, so we'll come back and discuss whether El Ninos really need a trigger or they can be explained as a stable oscillator. Are they really independent? If you say it's a stable oscillator, so doesn't need any trigger, doesn't mean that it has to have a period that is constant, because you can have noise in the middle. Even if recharge happens and warm water is heat content is available, it may not get released because of other factors, right? And we look at one of the strong candidates for this factor, which can generate changes in El Nino frequencies, their duration and their intensity and so on. It's called westerly wind burst. We don't understand all the processes by which the westerly wind bursts get produced, but nonetheless they are easily observed and they are almost always associated with El Ninos. So there are papers showing that without westerly wind bursts, you will not have strong canonical El Ninos, but lack of them can produce flavors of El Nino like Central Pacific El Nino. Okay, we'll come back and discuss that in the next podcast.